All right, thank you very much. And thank you everyone for being here and having the opportunity to talk tonight. Don't let that title throw you at all. We found out about this presentation on Wednesday and all somewhere else when the info was sent through to the AIG. But we're going to talk all about data management. Two parts of the talk tonight. First one I called the journey to date. Most of the presentation I gave last year for AIG in Queensland, and really it's looking at the last 30 years, our journey to actually work out that technical data governance standards and procedures, really important. And part two is the voyage ahead, sort of loosely, probably started 10 years ago when we really started looking at the opportunities with integration and automation. All right, normal disclaimer. So part one, the journey today. So we're going to look into technical data governance standards and procedures and what they look like, look at some real world case studies. I like to try and put dollars and examples against this stuff because it's very hard to get any buy-in if you don't. And then look at the common factors. Along the bottom here, we're going to see pretty much, I think most people accept that we need good people, processes, systems, and leadership to end up with a good data management scenario. All right. This talk does have some heavy slides in it, so, try and stay with me. Technical data governance refers to the overarching framework that defines how geological data is managed across an organisation. We're looking at who owns the data, who can access it, how it's stored, validated, sectored and shared, and ensures compliance with internal and external requirements. So what are we looking at? If I can find this guy. So ownership and accountability. End of the day, geos have to own the data. Geotechs have to own their data. We can't palm it off to unsuspecting DBAs to shovel, I won't say that word all the time. Data lifecycle management. We're fairly similar. Create, capture, store. We're a little bit different in the fact that we have interpreted data that also gets stored, and there's a whole realm of master data that needs to be handled there. And then where we're a bit different to a lot of data lifecycle management is we hang on to our data forever and use it as well. Data integrity and quality assurance, ensuring accurate, complete, consistent data. Security, confidentiality, more and more of a challenge this day and age with cybersecurity, and really it's about classifying our data and making sure we protect the sensitive information. And compliance, I'm sure you're all familiar with the JOR 43101 and company QA/QC. Moving on to our technical data standards. So referred to a set of defined rules and formats for collecting, recording, and interpreting data in organisations. Enforcing the standards ensures consistency, interoperability of data across teams, projects, and software systems. Rightio, so we're looking at data formats. We used to talk a lot about standardised file types. Now more and more our information is transferred in JSON as the standard format between coordinate systems, where obviously as much as possible want to collect original surveys and have systematic ways of them being transformed, not relying on individuals to do transformations. Coding systems. Look, we've got companies that do it really well, companies that have so much historical data they've never been able to transform their codes and support many coding systems. And I wear a hat in both worlds these days, on the hard rock and the coal world. One thing the coal industry did phenomenally well was standardising their coal log system. It took 10 plus years. I think it was 3 ACART projects, but almost, there's one company who's holding out, almost all companies now use a standard system across the whole coal industry. Yeah, really cool. Standardisation of metadata, how, when, who, and our QA/QC protocols. Moving on to technical procedures, step-by-step methods or standard operating procedures that define how data is collected, processed, and verified and stored in line with standards. Coming up in some of the case studies we've got, we'll have a look at, especially in the junior market, where they have good standard operating procedures in place. Normally things go a whole lot better than when they don't. And it's a maturity thing, right? All right, moving on to our first case study. Well, the first two are junior explorers exploring in North America. One good, one bad. So first one, leadership established strong governance standards and procedures which enabled successful project outcomes. So really importantly, the management spent 3/4 of their time in country. Starting with good governance standards and procedures. They set up standard logging. They dealt with all the historical data and converted it to a standard system. They had no transformations for all the historical cohorts. They went through, they used maps. It took about 4 or 5 iterations where they actually unpicked transformations and got them to a point where they were confident to use them and be able to use that data. They enabled 2 senior geos, like a lot of juniors. They have a lot of turnover of staff. They set up one of their seniors in a mentoring role, to mentor and supervise new geos, and the other one to look up their standard procedures. And then working with us at Plexa, we had a really good relationship. They had not large budget, but they were happy for us to provide them whatever ways that they could help unpick all the historical data, code conversions, and keep the costs as low as possible. The MD of the company estimated a positive impact of $1.5 to $2 million on that, based on 20% saving of year 1 and 2 costs through tighter drilling programs. So that's not just us. That's doing the whole lot well from the start and getting the data to the point where you can reliably use it, especially all the historical stuff. And unfortunately, this guy is probably retired now, but the resource geo gave a compliment to to everybody really, which was some of the best data he'd seen. Moving on to another junior problem statement. There was just lack of robust governance, which impacted everything really. The key drivers, the leadership was Australian-based, and the communication between the Australian leadership and the Canadian doing the work was horrendous, to say the best, really. Cost savings on initial migration introduced more errors. Poor change management, and the field teams that were contractors, they had their own processes, and the two just didn't mix right. They empowered their DBA to be real responsible, just didn't help him out with any governance or support. And essentially the historical data had a lot of issues. I mean, where this group was, I think the magnetic declination was 18 degrees. They either didn't corrected it the wrong way, up to 36 degrees out. And I spoke with one of the original founding directors. He goes, look, they go the same direction as the road. Okay, so when they're pointing the wrong way, it's the correction's wrong. Look, 6 months, there's probably 100K made up of consultants trying to fix things, resource geologists who delayed models. Yeah. Case study 3, tier 2 in the Laverton region, early 2000s. This is a starts bad but ends well story. So the problem statement, extremely poor repeatability of gold grades on a salt lake program. So initial 1 week investigation identified that there was some serious data corruption, given they had arsenic in their gold repeat columns and were averaging their gold and wondering why they had problems repeating the assays. The initial system was a text-based system. There was no governance, and it just wasn't fit for purpose for tier 2. So they actually paid a guy in Melbourne to come up with a migration process. He did a proof of concept, said it's a proof of concept, don't use this. So they used that and migrated it to access wrong people, shortcuts, save money, and that was the first really major. There's a lot more to the story, but yeah, it was a good one. Second one, they went, right, we should migrate to another system, a commercial access-based system, and they repeated the same mistakes again. And just to be certain, they did it a third time to a different commercial product. So three migrations. It was probably the worst series of events that I've seen in how to screw up a database. But it gets better. So utilising the lessons learned to uplift the data management framework. So we then did a 1 month exercise to rebuild that Salt Lake project from scratch, from every piece of raw data we could find. And we identified that there was significant missing data. We found drill holes that just weren't in their data. So following that, I said, hey, Craig, we've got another 20 projects. Let's go. So that was a second person involved, and there was a year and a half with 2 people to rebuild 20 projects for that group. There ended up being roughly about 20% of holes that they just didn't know about from the original data, and about 20% samples for the holes they did know about, that they didn't know about. They learned from that journey, and the following program was good processes, procedures, and a good success. So the cost back then, it was somewhere around 350, 400 to do that exercise. They estimated they added $10 million of drilling to their database that they didn't know about. So that was a pretty good win. There was a whole lot of additional value in missing samples, erroneous data, drilling on salt lakes when there's nothing below them, which they said also added value, but they didn't actually try and estimate that. Sorry about that. All right, a couple more case studies here. Tier 1, early 2000s, problem statement, multiple databases, inconsistent standards, duplicate data, issues with local grids up to 15, 20 metres out, and pretty much from exporting their data to using it in a model was a 6-week process of validation and fixing data. So they set up a couple-year project to consolidate the 5 databases and get some good governance in place. They got clear project sponsors from both resource and exploration, strong collaboration between external provider and the client, fortnightly training and mentor of geologists across all sites, and ongoing continuous improvement of processes and systems, really driven by on-site collation and prioritisation. So site drove where we took it. The result, high confidence in data, and our export now took the time it took to run the export rather than 6 weeks. My favourite quote in that 2-year period relating to our little grid problem was, maybe that's why we have ore in our ramp. It's the wrong spot. So cost impact. Maybe putting the pit in the wrong spot costs us a fair bit of money. But directly relating to this 6 weeks to clean up data, somewhere around 40 to 60K per model, and they're doing 5, 10 models a year. So it was costing them a lot. And the last case study of this section, the recent geotechnical example problem, millions of dollars spent on testing, which just wasn't available. The data is in silos by individual geotech engineers. That's amazing, isn't it? Geotech's holding onto their data. No centralised system, lack or unknown state of validation, and basically in the absence of actually having usable data, they're using generic factors on wall angles and stuff. Again, good story at the end. Governance of geotechnical data was established, championed. It was probably one of the best geotechs I've worked with. They set up the whole data lifecycle management and really pushed site geotechs to be part of it and own their data. The geotech labs are engaged. We've got standard test reports from geotech labs, which is also amazing. All the historical data was compiled and there was a joint venture with us and them to migrate all that data and make it available. And they went back and all the geotechs validated the data that was compiled. So they went from nothing they could use to high data confidence, where real values could be used in pit wall designs and data visualization tools. So millions of dollars worth of data. I'm using the extreme poetic license on this bit because it's sort of conversations. I had a conversation with the GM of the site, and he said, "Look, preventing wall failures on this one mine over 5 years is probably 40 million bucks worth." So, and then this one is actually, from when I used to work over here, 1 degree of additional wall angle at one of the larger iron ore mines in WA was estimated to be around $150 million. So being able to actually use proper geotech factors and steepen the wall up just has huge, huge financial benefit. All right, here comes the sailor in me. So, got to make it a bit interesting. Common traits of a successful data management void. You need supportive captains, leadership that chart the course and stays the heading. Every one of those successful projects had a good leader. Passionate first mate, so empowering champions who rally the crew. And a culture of seamanship. Everyone understands the value of reliable, usable data. Key message, even the finest ship and maps mean nothing without a strong crew and clear leadership at the helm. When done right, governance steers the vessel toward treasure, not turmoil. Technology builds it, but people have to sail it. All right. Not two. That's away. This is good. All right. All right. So the voyage ahead, as I said, we're going to have a quick look at modern geological data and how we manage the growing volumes of data. Look at automated workflow examples, a couple of practical examples, and then some real-world case studies again. Surprisingly, we've got people, process, systems, and leadership still. It doesn't go away, and if we throw them out the door and expect them to be replaced by automation and integration, we're gonna end badly. All right, what do all these groups have in common? All generate vast amounts of data, and the possibilities are only growing. I probably could have done 3 slides, of all the groups now that are generating data. There's great machine learning, there's great AI, there's some really crap as well. And it's getting easier for people to come up with great ideas. It's just getting harder to manage all that. So APIs, or application programming interface, enable these systems to be integrated and data acquisition to be automated. What's this do for us? Reduces repetitive handling of human error drastically. What doesn't it do? It doesn't remove the need for oversight, validation, and quality control. Key message is that connected systems still need an authoritative source of truth and strong quality controls. All right, you're going to have to hang in with me for a few slides here. I'll try and get through them. The first one is, and again, these are just my examples. People do it differently, and that's completely fine. But we're looking at a land disturbance example where we're taking a drill pad from planned, getting the land access, survey ground truth, getting a program of work approved, doing the land disturbance, making the pad active and available, and then the bits that often fall apart after that, the rehab and the finalisation. So, and we've got our framework elements over here. So we're going to import our drill pads with associated holes. Our land access, we're looking at all the requirements that we need to go put boots on the ground. And look, maybe people who are a bit more familiar with other systems, as far as I see, it's very still people and process driven. There's no magic that sort of happens there. Our survey ground truthing, getting someone out in the ground to say, hey, we can't drill where the tree is or where the gully is, I need to move this hole. But what we should be looking for is that those new locations can be captured by that field person. The comms now are better and better, with Starlink being more prominent. And with comms, he can get on the phone to the project geo and say, I've moved the pad 100 meters. Can you still drill your target from there or not? And they can look at that data live. Our program of work, obviously things have improved with the department over here, but it's still a fairly manual process. Our land disturbance, when we go prep the pad, again, we can have the operator capture that the pad's been prepped, where the peg's actually been put, and that can trigger an automated event to then make that pad available. And now the drill holes associated with the pad can be made available to a logging system. So everyone knows pad's there, let's go. And if you really want to get into it, some of our clients then go, oh, can you assign our hole numbers while you're there? Because once we've got a pad, we're happy to do it. Others say stay right away from that. So we go and drill our holes, we track our data, we finalise our drill holes through some sort of hole completion report. So now we can add some automation to say, once all of the holes on that pad have been finalised, we want to make the pad available for rehab. And we go out, rehab it, flag it as finalised, take some pretty pics, and we have proof that the job's been done. Right, moving on to a drill hole data example. So a bit of a change on how we're looking at it. Just looking at different data sets and how we can look at integration and automation. They're not exhaustive, they're more ideas on where we're going or where we can go. Now, our field logging and sampling, these days, probably half our clients are doing it online directly into the portal or with Starlink on the rig, and the other half, offline app. Whichever way, we want it validated in the field at the source and seamlessly synced to the database. Our drilling data, we should be looking at integration. That most people have gone down the path of some plod system, a call plan or a crux. We want to be able to grab that data seamlessly and pull in our drilling data. We may want to get consumables, but minimum we want to know depths, hole type, so we can use that with our other data. Our final collar survey, there's some pretty cool things happening there. Rigs are being set up with DGPS, so that data gets synced to those systems and we can pull them directly. One of those clients in North America, they're going to wait till they've done their drilling program, fly detailed drone imagery and digitize their final surveys on a map, and they reckon they'll get under 10 centimetre accuracy, which is pretty cool for an exploration program. Downhole survey, again, we've got the likes of Index and Access Connect. All the data from the tools is pushed up to their cloud systems and we can automate pulling that down. Handheld tools are getting better and better. We should be looking at where we can integrate directly with those rather than dealing with CSVs and Excel. And then we have a phenomenal amount of external suppliers producing great data, hopefully sometimes, from machine learning and AI models. And we want that stuff to be also synced. Was at the Brisbane Mining Geology National Geology Conference a few months ago. It was a great talk by one of the miners over here who had implemented an external supplier with their core yard and RQD and recovery processing. Don't quote me on this, but I think they got their core yard process down to about 30% of the original time, which is huge cost savings. So there's some good wins to be had. Photo world, there's a plethora of people doing photos, we collect photos. The key thing for me is we want to be able to pass these photos between systems seamlessly and pick and choose who does what. If one supplier does great machine learning for lift and the other does better RQD, want to be able to just pass those photos around and get those data sets back. Our dispatch, these days some of the labs have API endpoints that you can actually put the dispatch directly from your data management system into the lab's LIM system, reducing transcription errors on the lab side. And then on the flip side, we can pull the analysis templates that have been agreed so that when you're doing your dispatch, you don't have to pick MS61 with an ore grade method and I want you to do this. you've already agreed that, and you just pick the template that you've already discussed with the lab as part of your dispatch. Sample reconciliation, again with the data coming through the lab's APIs. As soon as the lab registers the sample, often on day one, we can reconcile those samples against the ones in the database and be resolving any sample issues. And then we can pull the data automatically in our database through the lab's API and push it through to our QA/QC process. QA/QC checks and graphs. We're really looking at the system being able to help out the geo. We want to have the charts automated. We want cut-offs and ranges or standard deviations identified so that the system will have a first cut and go, we reckon it's 80% of it's good, go look at the other 20%. So still need geologist approval and geologist input, but we can help them out a lot. And then finally, the drill hole completion phase. Again, we can automate a lot of that, sort of green ticks and red crosses, but we need a geologist to say, you can go grout that hole, we're done. And at the end of the day, my mind, we're heading for the rig to model as much as we can automate that process whilst maintaining everything we talked about around data governance and processes. Right, we've got 3 case studies here on some of the benefits. So large mining company, benefits of automation and integration. What changed? Well, they implemented Plexa, but what actually changed was they implemented some integration and automation workflows. So seamlessly logging and seamless logging and photo capture, synchronized back. I'm not sure if you were in the coal world, they take a picture every half meter of the run to generate a lot of photos. Directly uploading data from the suppliers, so some of their downhole geophysics, the supplier can basically push the file up through an API endpoint and have it automatically processed. Integration with pod systems, bidirectional integration with ArcGIS Online through allowing them to use field maps for their data acquisition as well. Measurable benefits, essentially they had a 40% reduction in their support tickets in their first financial year after implementing the automation, a further 20% in the second financial year. The support requirements reduced from 3 full-time employees to 1. That's not a bad story, that's a good story. What that enabled, database professionals shifted from full-time support to high-value projects. Geologists empowered to get more value from the data through API-enabled self-service and using tools like Power BI, Python, machine learning, etc. A couple of full-time people, the real cost of a company, you can probably double their salaries or something like that. We're talking 400 or 500 grand. So business value, technical capacity redirected to high value roles, resulting in, something like that annually, reduced ongoing support burden and staff retention through career development opportunities. If you've ever just fixed someone else's data for a career, it gets tiring eventually. But there's the other side of the coin, the professional value. Greater geologist self-service, development of modern skills and analytical skills, and more time spent on technical, meaningful work. Next one is a story of data administrator technical, a smaller company, probably mid-size. Prior to the improvements, the full-time database was writing bespoke scripts, Python and stuff to deal with field data coming in and validate it and combine it. Quite significant time back and forth between them and the geos, time processing assay data, and this all ended up being one full-time person. After improvements, integrated systems, automated data workflows, the validation was essentially pushed through to the point of data capture. The routine processing and validation was automated. So what did this enable? The geologists able to collect high quality data with fewer errors at the source. The DBA capacity redirected from routine processing, troubleshooting to high value technical work. The first thing done was almost moved to working full time on those projects, and actually did an in-house AI project to convert all of their historical data that was just dumped on a drive to registered depth strip imagery. So they pulled the old Cyro logic on how to pull a photo apart, and use a lot of AI to read depths off the core trays, and produced a phenomenally amazing, useful set of photos for their whole company. Value, probably 200. Again, enabling the business to use existing resources, and freed from repetitive data processing, troubleshooting, able to apply skills to advance rewarding projects and develop innovative solutions. Final one, doesn't always go right. All right, probably around 5 years ago, but sometimes 5 means 10. Power BI and Spotfire came on the scene, and great tools, but what we saw in a number of large companies is technically capable people, employees, started creating dashboards by the dozens. They were built and maintained by individuals, and this expanded the reporting across the organisation very quickly. People loved them. What went wrong? There was no governance, there was no documentation, and the quality control was out the window. The reports became difficult to support and maintain, incorrect and conflicting data, really similar story, no source of truth. What happened? Managers start going, why are these numbers wrong? And they get really upset. So the solution was to properly map out and standardise the workflows, systemise the collection of data to a centralised data warehouse, implement quality control procedures, and establish ownership. When you look at this sort of scenario, and again, this is my take on the cost. You know, we were seeing people spending a quarter of their job playing with dashboards and wrangling data and making it look good, and then maintaining it. You know, you can put maybe 50K on that, but across this organisation, there were 10s or 50 people doing this. They were just, so that number gets big. Business impact, conflicting data, forming decisions, duplicated effort across teams, key person dependency, unsupported reporting, professional, repetitive reporting and rework, time diverted from actual real technical work, and frustration everywhere. All right, to wrap it up. So, technology and automation synergies. So, in the technology world, integration, Starlink's been a big game changer for whole mining industry. The sailing world, especially ocean sailing, has been massive, having access to data where you'd go weeks or more. It provides live weather updates, you know, at the touch of a finger. We've had systems like the NEMA 2000, which integrate everything on your boat, from the odometer on the top of the mast, to your auto helm, to your maps, to everything. Unfortunately, it just doesn't always work. Automation, with auto helms been around, there's manual auto helms, there's mechanical ones. They also stop at random. And these days, weather routing, there's fantastic apps like Predict Wind. You put in where you're going to leave, put in where you're going to go to, and it'll give you 5 routes based on 5 weather models. And you don't have to put too much thought into it until it goes wrong. So over here, we've got planning. So it's actually a legal requirement on any boat to do a passage plan. If you're in your tinny going from down Frio, your passage plan is I get in my tinny and drive there, right? It's actually still a legal requirement. When you look at ocean passages, you need to be looking at where you're leaving from, the conditions, where you're going to. You need to consider alternate routes, where you go when it all goes to shit. You need to have a watch schedule. Things break in the middle of the night. Boats, ships can come your way. So again, this is people, it's process, and most of all, it's leadership by a skipper. Key message, it's a great quote. There's two types of sailors, those who run aground and those who lie about it. Automation integration will go completely wrong at times. Guarantee it. You need to make sure that you have a plan in place, just don't rely on it, and that you also have the experience in place to deal with it when it happens. No matter how advanced the ship, it can steer itself through a storm without a steady hand at the helm. Again,